So in this video, we are going to study about the basics of the signals. Now this is the very important topic and the very important video if you want to master the signal and system subject. Okay, let's start with the types of signal. We have the three types. Now these are the very important types, these two. So let's have a look on these two types. First we have the continuous time signal and the initials as C and T. I am basically writing it as CT. Now most of the time the examiner states the problem in such a manner like if we have a CT signal, this means if we have a continuous time signal, then the rest problems. Okay, so the variable used is T, and if we talk about the discrete time signal, we have the initial as DT and the variable used is N. So basically the example is framed as x of t is input, y of t is output, and h of t is the impulse response. Now this x variable is the input, y is the output, and h is the impulse response, whereas this term, this represent our signal is continuous time. Similarly, you can see here x of n, y of n, and h of n. So this is the main type, continuous time signal and the discrete time signal. We will master this topic in this video by seeing the varieties of the function. Okay, and then we have this digital signal. Now this signal is used in the digital logic design. Many of the time you have seen this signal as the 0 volt 1 volt output. Okay, so this is the digital signal and example is the DC voltage. Now let's move forward to the representation of this signal. So let's see the representation of this three signal. First was the continuous time signal. Let's say our example is x of t is equal to a sin t. Now a here is the amplitude and this sin t. So basically omega is 1. So sin omega t is the function and we are putting omega is 1. So we are getting the sin t. Now we have to plot this. So in the x-axis we have the time, in the y-axis we have the amplitude. Okay, let's plot. Let's say omega is 0, then I will get sin 0. Sin 0 is 0, then I will say omega is pi by 2. So sin pi by 2 is 1, but our amplitude here is what? A. So we will get A here. Then similarly sin of pi, this is what? This is 0. Sin of pi is 0. Then we have sin 3 pi by 2 and then we have sin 2 pi. So 3 pi by 2, our amplitude is negative. So this is the representation of a continuous time signal and the function was x of t is a sinusoidal function with amplitude A. If we want to convert this continuous time signal to the discrete time signal, we are using the sampling theorem. Okay, and if you want to understand the sampling theorem, please do comment if you want to understand this topic in depth. Here we will see the representation part. So now my function is x of n is equal to a sin of n. So the important point was about the notation. T basically means the continuous time, n means the discrete time. The function remains same, as you can see, a sin of n. Okay, so again we have the a as the amplitude and here also omega is 1. Okay, let's see how we can plot. Here we will not use t, okay, because we are in the discrete time domain, we are using the n as our notation. So again amplitude and the time, which is represented as small n, and as you can see here the envelope is not present. If we connect this envelope, this is a continuous time signal, but at particular value, at n is equal to 0, we are getting some amplitude. At n is equal to, let's say, some fraction, okay, some fraction, we are getting another amplitude, and so on. As you can see, this all are the amplitude, and the important point to note down, between these two signal there is no amplitude. Okay, so this part is blank, there is no amplitude here. So discrete time signal gives you the amplitude at some specific point, as these are the specific point. So this was the representation of a discrete time signal, and these are the digital signal, as we have already seen in the previous slide that this is the voltage, DC voltage. So this is the time, that is t, and this is the amplitude. As you can see, for some interval this DC voltage is on, for some particular interval it is off, and again it is made on. So this was about the representation. Now let's look at the special functions. So let us study the continuous time signals first. So the first function, or you can say the first signal we have, is the impulse signal. So what is the equation of the impulse signal? Let's say x of t is equal to delta of t. So delta of t is the notation, and now this signal works at t is equal to 0. For any other value of t, it can be positive or it can be negative. For any other value of t, the function is not working, the value of the function is 0. So now this is interesting. If you plot this graph, so again we have the time, so at x-axis we have the t as the variable, in the y-axis we have delta of t. So we are plotting at t is equal to 0, our amplitude is infinite. Now this is the ideal condition. Practically we never get infinite, we will get some value. So in the practical condition, how we will find that value? So again we have this x-axis, this y-axis, and this is the strip we are considering. So the width, as you can see, the width is delta. Suppose it is very small, so let's say delta, and the height is 1 by delta. So the area would be width into length. Okay, so width into height, and if you are doing that, so delta into 1 by delta, this is our area. Now the area is 1. Now this is the practical condition where you are getting the area 1. Now what if I say instead of delta of t, it would be phi delta of t? Now this question would be solved in the note, so that is the different case, but I want to give you one more important point. So when I talk about the area is 1, area means integral under the curve, correct? So you can say that integral minus infinity to infinity delta of t dt is 1. Basic understanding that area under the curve, either you can say the area is length into width, or you can say the integral. Okay, so these were the two important style that you have to follow. If we have integral minus infinity to infinity delta of dt is equal to 1, this is a unit impulse signal. So unit basically means the amplitude is 1. Now my question was, what if I did phi delta of t? So phi delta of t basically means you are putting the amplitude. If you are putting some amplitude in this function, then you will get the answer as a. Now this a is again valid at t is equal to 0. For t is equal to infinite, the amplitude is 0. So you should have that basic understanding. And if the examiner says what is the value of integral minus infinity to infinity phi delta of t dt, you should say that for any other value minus infinity to infinity, you are taking the range minus infinity to infinity. This signal is working only at t is equal to 0, and the answer would be its amplitude. So you are giving me phi as the amplitude, the answer would be phi. Now let's move forward to the next signal. So our second signal is the step signal, very important. So the first three signals are very important because maximum time examiner will use this three signal. Now the step signal is simple, x of t is equal to a. Now this is working only when t is greater than equal to 0. So basically in our time domain, if you are talking about the origin, that is t is equal to 0, and if you are moving forward in the positive side, this signal is working. For the negative side, this is the negative side, this signal is not working. So this is the plot. As you can see, x of t is equal to a when t is equal to 0 or t is greater than 0. So this the amplitude is a. If this a is equal to 1, the name given as unit step signal. So whenever you see this unit, okay, before any signal, this basically means our amplitude is 1. Very simple point, okay? And so this is the important note. And the important point is also this unit step signal is represented as u of t. So if u of t is present, this means we are talking about the unit step signal. Now this is the third important function, that is the ramp signal. Equation is simple, x of t is equal to at where t is greater than equal to 0. Again this function is valid for t is equal to 0 and when t is positive. Otherwise this function is not valid, this function has the amplitude 0. Now when we plot this graph, this is interesting. Again we have the time and x of t. When my t is equal to 0, you have to put this in this equation, x of t is equal to at. When my t is 0, then x of t is also 0. That's why you are getting the amplitude as 0 here. If my t is equal to 1, then you can see when my t is 1, my amplitude is a into 1. When my t is 2, my amplitude is 2 into a. So you can see here, this is what the value of x of t would be. Every time you are substituting the value of t and you are getting x of t. So this is the linearly increasing graph, and you will see the properties of this signal in the later videos. So the note is, if a is equal to 1, then the symbol x of t would change to r of t. So this is the ramp signal where you will say that our a was 1, so 1 into t is t. Correct, and this will work for t greater than equal to 0. For the negative values, this function is not valid, so the answer is 0. And again, if amplitude is 1, it is unit ramp signal. Okay, let's move forward to the fourth signal. So our fourth signal is the parabolic signal. Again, the equation is simple, x of t is equal to at square by 2. Now this is working for t is greater than equal to 0. Now you have to note three things. That first was, when I talk about the delta function, it is working at t is equal to 0, but the unit step signal or the ramp signal or the parabolic signal. Okay, this three signal are working when t is greater than equal to 0. So this is very important because this four signals or the upper three signals, maximum time Laplace transformation or any property related questions are asked on this three signal. So you have to take a special care that this three signal, okay, this three signal, that is the u of t, r of t and p of t, they work at t is greater than equal to 0. Now if you plot this, it is a simple, it's a parabolic curve. So what you have to do, you have to put the value of t and you have to get the value of x of t. So I put t is equal to 0, I will get x of t as 0. If I put t is equal to 1, I will get a by 2, that is 0.5a. If I put t is equal to 2, I will get 2 square, that is 4 by 2, that is 2a. So this is how a parabolic signal looks like, and I hope you got the basic idea between the delta of t, u of t, r of t and p of t. So the fifth signal is the unit pulse signal. Now this signal is made with the help of the unit step signal. So this signal is made with the help of unit step signal. So for that you should have the knowledge of unit step signal. Now these are the operations like the advance and the delay. You will study in the operations on the signal, so you don't have to worry about the logical explanation of that. You should know the equation and you should know the graph. So the main motto is that. So x of t is equal to u of t plus half minus u of t minus half. U of t plus half basically means your time is shifted to minus half. So minus half is what our t is, and if I talk about t minus half, this means that our time is shifted to half. So these are the operations, that is the advance and the delay, and the logical meaning is advance. The thing that should happen at t is equal to 0, it has the advancement. This means that it will not happen at t is equal to 0, it will happen earlier. That is the meaning of advance. If you are taking the delay, that t minus half, the thing that will happen at t is equal to 0 will take some time. It will take the half second more. So basically the original graph for t is equal to 0, because it is doing the work fast, so advance will start at minus half. Because delay taking some time, so it will start at t is equal to half. So this was the meaning. So how the operation on signals logically looks like. So if you subtract this term minus this term, you will get the unit pulse signal. So the pulse signal basically means that the time interval is 0.5 minus of minus 0.5. So the time interval is 1, and in this time interval our amplitude is working. That means our signal is working and the amplitude is 1. For the rest of the values, again we have the amplitude as 0. So this is how the unit pulse signal looks like. Now let's move forward to the next signal. So these are the easy signals. We have x of t is equal to cos t, then we have x of t is equal to sin t. Now x of t is equal to cos t, you have to basically put the values of omega. So omega is 0, like the t is 0, okay. You can basically say omega or you can say t. When t is 0, you will get cos 0. That is 1. So at t is equal to 0, you are getting maximum value, okay. When my t is equal to pi by 2, then when my t is equal to pi, then 3 pi by 2. So what are the changes we are getting? We have to plot that, okay. And when my t is equal to 0 in sine, okay, so when my t is equal to 0, amplitude is 0. When my t is equal to pi by 2, sine pi by 2 is maximum, that is 1, and so on. These are pretty simple signals, so no need if you know the trigonometry well. Now these two signals are very important in signal and system. X of t is equal to e raised to at, x of t is equal to e raised to minus at. So e raised to at basically means we can put and we can analyze the signal. If we have to plot the signal, put the lowest value. Lowest value means I can say t is equal to minus infinity, the very lowest value, and put the highest value, that is t is equal to infinity, and also put t is equal to 0 and check what is the value of this signal. If I put t is equal to minus infinity, I will get x of minus infinity is equal to e raised to minus infinity. Now e raised to minus infinity basically means my value is 1 by infinity. And when my value is 1 by infinity, the answer is 0. Simple. So at the extreme end, at the lowest, t is equal to minus infinity, we are getting the output as 0. And when I put t is equal to 0, I will get a gradual increase in my graph. At t is equal to 0, I will get e raised to 0, that is 1. So this amplitude is 1. And when I put t is equal to infinity, I will get e raised to infinity, okay. So e raised to infinity is again infinity. So you can see an increase in the graph. If I take the reverse of that, e raised to minus at, put the values again, t is equal to minus infinity, t is equal to infinity, t is equal to 0, and see the changes. So when I put t is equal to 0, again I will get 1, but when I put t is equal to minus infinity, I will get e raised to minus infinity into minus. So this is actually e raised to plus infinity. E raised to plus infinity, this means our value is infinite. If I put t is equal to infinity in this function, I will get e raised to minus infinity. So this is 1 by infinity and the value is 0. So most of the questions are based on the stability part. This function is convergent, divergent, this all concept will be dealt, okay, and maximum time examiner will take this two function for region of convergence. So I hope you are getting the basic idea that e raised to at is increasing exponential function, e raised to minus at is decreasing exponential function or decaying function. So the 10th signal we have is the sync signal. Now this signal is famous in digital communication because of the orthogonality purposes. Okay, let's go for the equation and plot. When we talk about the equation, x of t is equal to sine t by t. So in the limits, okay, in the limits you have studied that if we have sine of theta by theta where theta tends to 0, then the answer is 1, correct? So what was the reason behind that? We will see by the graph, okay. So sine t by t, this is working for minus infinity to infinity, but when my t is 0, I am getting sine 0 by 0, which is actually 0 by 0 and indeterminate, nobody knows indeterminate, okay. So basically we have to use the L'Hopital and we have to get the answer. So if you use the L'Hopital, you will get cos theta by 1, okay, and using the L'Hopital basically means take the derivative of the numerator and then take the derivative of the denominator and then put limit theta tends to 0 if it is not indeterminate. Now if you put theta tends to 0, you will get cos 0 and the answer is 1. So at t is equal to 0, you will get the maximum amplitude 1, but if you move forward to t is equal to infinite, you will get the minimum value. So at x is equal to 0 we are getting the maximum, at t is equal to infinite we are getting the minimum value.
तो फ्रेंड्स, अगर आपको मेरी वीडियो पसंद आ रही हो देन टू लाइक दिस वीडियो, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब टू माय यूट्यूब चैनल. तो मिलते हैं अगली वीडियो में. टिल देन टेक केयर. दिस इज श्रेनिक जैन. पीस आउट.